Hey everyone! Welcome back to KnowledgeHeals, where we make math simple, clear, and fun for everyone. Today we're starting exercise 3.4 from the chapter Trigonometric Functions, based on the Class 11 NCERT syllabus. This exercise is a little different from the previous ones. Here, we'll learn how to use trigonometric identities to simplify complex expressions. With the right logic and some practice, you'll be able to prove identities like a pro. In this exercise, you'll focus on proving that left-hand side equals right-hand side using identities, simplifying trigonometric expressions, applying identities smartly and logically.
Our exercise begins in which we will find principal and general solutions of equations. So there are 4 questions now. We will see our first question. Tan x equal to root 3, let's move on to our solution. As tan x is positive, it is first and third quadrants. Tan x is equal to root 3, which makes tan pi by 3, which makes tan pi plus pi by 3, which is in third quadrant. So we get tan 4 pi by 3. So our principal solutions are pi by 3 and 4 pi by 3, as tan x equal to root 3, which is equal to tan pi by 3. Therefore, x is equal to n pi plus pi by 3 as per our rule. Therefore, n belongs to z is general solution. Let's go on our next question. Our second question is sec x equal to 2, which can also be written as cos x equal to 1 by 2. As cos x is positive, principal solutions are in first and fourth quadrants. As cos x is 1 by 2, we know 1 by 2 is cos pi by 3, which is equal to cos of 2 pi minus pi by 3 in fourth quadrant, that is cos 5 pi by 3. Therefore, principal solutions are pi by 3 and 5 pi by 3. Now, as we know in our equation sec x equal to 2, which is equal to sec pi by 3. Therefore, our general solution is x equal to 2n pi plus minus pi by 3, where n belongs to z. Another question is cot x equal to minus root 3, which can also be written as tan x equal to minus 1 by root 3. Since tan x is negative, principal solutions are in second and fourth quadrants. As we know, tan x is minus 1 by root 3, which is equal to minus tan pi by 6, which is equal to tan of pi minus pi by 6, as it is in second quadrant. That is tan 5 pi by 6. For fourth quadrant is tan of 2 pi minus pi by 6, that is 11 pi by 6. Hence, principal solutions are 5 pi by 6 and 11 pi by 6. Now, as we know, tan x equal to minus 1 by root 3, which is equal to minus tan pi by 6, which is equal to tan 5 pi by 6. Therefore, x is equal to n pi plus 5 pi by 6, and n belongs to z, which is general solution. Fourth question is cosec x equal to minus 2, which can also be written as sin x equal to minus 1 by 2. As we know, minus 1 by 2 is equal to minus sin pi by 6. Since sin is negative, principal solutions are in third and fourth quadrants. Minus sin pi by 6 is equal to sin pi plus pi by 6, that is sin 7 pi by 6. As we go in, fourth quadrant equation becomes 2 pi minus pi by 6, that is sin 11 pi by 6. Therefore, principal solutions are 7 pi by 6 and 11 pi by 6. As we know, sin pi plus pi by 6 is equal to sin 7 pi by 6. Therefore, x is equal to n pi plus minus 1 raised to n into 7 pi by 6, where n belongs to z is general solution. Now we will only find general solution of equations. Let's see question 5, which is cos 4x equal to cos 2x, which we can write cos 4x minus cos 2x is equal to 0. We will apply cos c minus cos d formula here. So our equation becomes minus 2 into sin of 4x plus 2x by 2 into sin of 4x minus 2x by 2 is equal to 0. As we simplify, it becomes sin 3x into sin x is equal to 0, which applies sin 3x equal to 0 or sin x equal to 0. Hence, it becomes 3x equal to n pi or x equal to n pi, where n belongs to z. Therefore, general solutions are in pi by 3 and n pi, where n belongs to z. Here, question 6 is cos 3x plus cos x minus cos 2x is equal to 0. Let's focus on solution, and we apply formula, so it becomes cos c plus cos d is equal to 2 into cos into c plus d by 2 into cos into c minus d by 2. So our equation becomes 2 into cos of 3x plus x by 2 into cos of 3x minus x by 2 minus cos 2x, which is equal to 0. 2 into cos 2x into cos x minus cos 2x, which is equal to 0. Taking cos 2x common. Cos 2x into 2 cos x minus 1, which is equal to 0. Thus, it becomes cos 2x equal to 0, or 2 cos x minus 1, which is equal to 0. 2x is equal to 2n plus 1 into pi by 2. n belongs to z, or cos x is equal to 1 by 2. X is equal to 2n plus 1 into pi by 4, where n belongs to z, or cos x is equal to cos pi by 3. Therefore, x is equal to 2n plus 1 into pi by 4, or x is equal to 2n pi plus minus pi by 3, where n belongs to z. Thus, we have found our general solution. Another question is sin 2x plus cos x is equal to 0. We will move to our solution, that is 2 into sin x into cos x plus cos x is equal to 0. We will take cos x common and it becomes cos x into 2 sin. X plus 1 is equal to 0. Either cos x equal to 0 or 2 sin x plus 1 equal to 0. So we get x equal to 2n plus 1 into pi by 2, where n belongs to z, or sin x is equal to minus 1 by 2, which is equal to minus sin pi by 6, which is equal to sin pi plus pi by 6, which is equal to sin 7 pi by 6. Therefore, x is equal to 2n plus 1 into pi by 2, or x is equal to n pi plus minus 1 raised to n into 7 pi by 6, where n belongs to z. Another question is sec square 2x equal to 1 minus tan 2x. We will use sec square theta formula and substitute it so it becomes 1 plus tan square 2x equal to 1 minus tan 2x. Tan square 2x plus tan 2x is equal to tan 2x. As we further simplify it, we get tan 2x equal to 0, or tan 2x plus 1 is equal to 0. As we move more, we get 2x equal to n pi, where n belongs to z, or tan 2x equal to minus 1, which is equal to minus tan pi by 4. That is equal to tan of pi minus pi by 4, which is equal to tan 3 pi by 4. As we simplify more, we get our general solutions. They are x equal to n pi by 2, or x equal to n pi by 2 plus 3 pi by 8, where n belongs to z. Now let's focus on last question of our exercise, that is sin x plus sin 3x plus sin 5x equal to 0. We will apply identity now as sin c plus sin d equal to 2 into sin c plus d by 2 into cos c minus d by 2. As we apply formula, we get equation 2 into sin 5x plus x2 into cos of 5x minus x by 2 plus sin 3x is equal to 0. So it becomes 2 sin 3x into cos 2x plus sin 3x is equal to 0. As we simplify more, we get sin 3x is equal to 0, or 2 into cos 2x plus 1 is equal to 0. Thus, we get equation codes of pi minus pi by 3 equal to cos 2 pi by 3. Thus, we get our general solution as x equal to n pi by 3, or x equal to n pi plus minus pi by 3, where n belongs to z. Alright friends, that wraps up all the questions from exercise 3.4 of the Trigonometric Functions chapter. We explored how to find principal and general solutions of trigonometric equations using identities, graphs, and logical reasoning. Remember, practice is the key to mastering these equations. Don't just memorize the formulas, understand where they come from and why they work. If you still have any doubts or want a deep dive into any question, just drop it in the comments. I reply to each one personally. And if you found this video helpful, don't forget to like, share, and subscribe to KnowledgeHeals, because here we make maths not just easy, but also fun. See you in the next video with more concepts, more questions, and more clarity. Until then, keep learning, keep growing. Let me know if you want a Hinglish or Hindi version of this too.